So we're going to take a look at how we can take a quadratic function that is in standard form and put it into vertex form. And in the warm-up in class, we went the opposite direction. So we took something that was in vertex form, and using FOIL, we expanded it out and put it into standard form. So we're going to go the reverse. And so this is all kind of based on knowing that if you have something that's called a perfect square trinomial, it can be written as a square binomial. So in other words, like, x plus or minus something squared. And so in order to go to vertex form, which has something that looks like a square binomial in it, the first thing we want to do is check to see maybe we already have something that will easily switch to vertex form. In other words, something that's already a perfect square trinomial. And in example 1, x squared plus 4x plus 4 has the pattern of a perfect square trinomial because it starts with a perfect square, ends with a perfect square, and the middle term is twice the product of the two square roots. Square root of x squared is x. The square root of 4 is 2. If you multiply them and double it, you get the middle term, and that makes a perfect square trinomial. Now, the sign only really matters whether this is going to be a plus or a minus binomial, and because that's a plus in the middle, it must have been a positive 2 for the square root of 4 instead of the negative 2. And so that x plus 2 squared is equivalent to x squared plus 4x plus 4. So that's in vertex form now. It's just that there is no k off the end. It's just the slide up or down is none. There's 0 and there's no stretch or compression, but it is still in vertex form. So f of x is equal to x plus 2 quantity squared, and the vertex then would be at negative 2, 0. So what about if you don't have a perfect square trinomial to start? And I can tell that this is not, because 18 is not a perfect square. So in that case, because that 18 is not a perfect square, we don't really want to deal with it. We want to just get rid of it. We'll do that by moving it to the other side by subtracting 18. And when I move it to the other side, then that kind of clears the slate on this side to now create my own perfect square trinomial. And so I actually have to work backwards. So I know that that middle term was twice the product of the square root. So if I go backwards, if I take half of negative 8 and then square it, I should get what it would take to make this a perfect square. So whatever I add, then I'll add to the other side as well, because of course the addition property of equality. So half of negative 8 is negative 4, negative 4 squared is positive 16. So adding 16 to this side, which would then add 16 to that side, now creates this perfect square trinomial that I can rewrite as a binomial squared by taking the square root of the first, which is x, the square root of the last, which is 4, and the sign comes from the middle term. So now I've got that piece that looks like vertex form that shows me the horizontal slide part, and then all I have to do is then clean up the other side. So when I add these together, this makes f of x minus 2, so then I'll have to add 2 to the other side to bring it back over, and leaving me with f of x is equal to x minus 4 quantity squared plus 2. And so now I can see the vertex of this is at 4, 2. So that's for a basic one. Okay, so let's take a look at a little bit more complicated one. So this time our function in standard form is negative x squared plus 6x minus 5. So what do we do if there's a leading coefficient or just a leading negative, which means obviously there's some kind of reflection over the x-axis going on here. So first of all, what that does is it makes it so that that is not a perfect square trinomial right off the bat. So not only is this minus 5 not a perfect square, and so we want to swing that over to the other side. I'm just going to go ahead and add it to the other side to kind of just get it out of the way. But I'm also worried about this x squared being negative, because that makes it not a perfect square. So how could I get rid of that negative? Well, I could just divide out the negative, or divide out a negative 1 about off of what's left over. Well, what's left over is this. So if I divide that negative out of both of those, that leaves me with a positive x squared and a negative 6x. So basically what I just did is divided each of these by negative 1 or by the negative. And now I can then just target in on this x squared minus 6x and figure out what do I have to do to complete, make that a perfect square trinomial. And so I'm going to look at that middle term, negative 6, take half of it, which is negative 3, and square it, which makes 9. But in effect, what I really did on this side was add negative 9, because there's the negative out in front. So were I to distribute that negative back through, that would make that a negative 9. And so that's actually what I have to add on this side. Oops, I didn't leave a spot for it, but add a negative 9 on the other side as well. oops, you can't see the negative there, you can. And so that kind of keeps it in balance. Well, then it makes this other side be f of x minus 4 then, because the negative 9 and the positive 5. On this side, I can now go ahead and take the perfect square trinomial that I created and write it as a square binomial by square rooting the first and the last, which is an x and a 3, and using the sign on the middle term. And now that's equivalent to x squared minus 6x plus 9, and then having the negative out in front takes care of that reflection over the x-axis. And the final step is now swing that 4 back to the other side by adding it, and now it's in vertex form as f of x is equal to the opposite of x minus 3 squared plus 4. So the vertex is at 3. Now what about if there is a coefficient in front of the x squared? Even if that coefficient is a perfect square, you really don't want to have to try to worry about how to make a perfect square trinomial if the leading coefficient is not 1. It's because that rule we learned about taking half the middle term or half the b and squaring it, that only works when the quadratic starts off with x squared. So that would be something we'd want to take care of, just like we took care of the negative on the last question. But step 1 is, of course, looking at the last term, seeing if that's a perfect square, and of course it's not. So we're going to swing that over to the other side by subtracting it. That's kind of step 1. Just move it out of the way just to make things less complicated. And then that's going to leave you with this 2x squared minus 12x on this side, right? And because I've got this 2 here, I could just divide that 2 out. And if I divided it out of both of these, that would make the first term now x squared and the next term be minus 6x. So now I'm in a position where I can go ahead and start completing the square here, because now if I just target in on the x squared minus 6x, then I know that I'd have to add a 9 to make that into a perfect square trinomial. But in effect, what I did is added 2 times 9, or 18, to that side. So when I go over here to the other side to offset the effect of adding that 9, which is really 2 times 9, I'm going to add 18. So again, 2 times 9 is 18, so I'm adding 18 on the other side to keep it in balance. When this cleans up, that's going to make this f of x plus 5, because the negative 13 and the positive 18. When I factor the perfect square part, there's still that 2 out in front, which basically means it's a vertical stretch of 2. And then writing this in as a square binomial would be x minus 3 squared. And then finally swing that 5 back over to the other side to get it in vertex form. So f of x is equal to 2 times x minus 3 squared minus 5. And that means the vertex is at 3 minus 5, or negative 5. And this is also a vertical stretch at that point. And let's look at one last example here. So what if not only do we have a negative out in front, but let's say the middle term is odd, okay? So that's going to make things much more complicated. So step 1 is always kind of look at that constant term in the end and see if that's a perfect square. And of course, minus 22 is not. So if you swing that over to the other side by adding it, that would make the f of x plus 22. On the other side, we have negative x squared minus 9x. And I want to take care of this negative. So just as we did in the prior example, we would factor out that negative, or negative 1. You can think about either way you want, or just negative. And if I factor out a negative, that's going to make this first term x squared and the next term plus 9x. Didn't do anything to the other side because I'm just factoring out of these 2 terms. But now I'm going to figure out what I have to add here. Well, this time that middle term is odd. So using that little formula of taking half the middle term and squaring it would mean that I'm having to take half of 9, which is 4.5, and square that. Now, I think it's almost easier to do it as a fraction, but you certainly can use decimals and use 4.5. But when I square a fraction like that, I just have to square the top and square the bottom, so that makes 81/4. So what I'm really adding here is 81/4, but in effect, a negative 81/4 because of the negative that I factored out in front. So on the other side, to balance it out, I'm going to subtract or add a negative 81/4, which, by the way, is 20.25, I believe. So that would be like subtracting 20.25 from 22, and that's going to leave you over here with f of x plus, so 22 minus 20 0.25 would leave me with 1.75. If you want to use decimals, again, that's completely fine. And that's going to be equal to the opposite of, and then we're going to factor our perfect square trinomial down to a square binomial. So the square root of x squared is x. The square root of 81/4 is 9/2 or 4.5 if you'd rather use decimals. And then the sign comes from the middle, which makes it a plus. So final step is subtract the 1.75 from both sides. And now it's not pretty, but it is in vertex form. X plus 4.5 or 9/2 squared, and then minus 1.75. That's going to make the vertex at negative 4.5 and the y coordinate of the vertex at negative 1.75. And this will also be a reflection over the x-axis. And of course you can always graph these two on your graphing calculator to verify that in fact they are equal by showing that they have the same graph. So I went ahead and typed in the original and what I got for vertex form. And I'm just going to go ahead and graph them at the same time, and we're going to see if that's the same graph. And you can see that red graph going right over top of the blue, and that's my graphical verification that in fact those two forms of the quadratic are equivalent, one in standard form and the other in vertex form.